Hello developers, you are interviewing for a senior iOS role at a company that ships a production app used by millions of people. The interviewer looks at your resume, nods, and asks, "Can you walk me through how the Objective-C runtime handles message dispatch?" It is 2026. You have been writing Swift for 5 years. And this question just made you freeze. Here is the truth. Companies with large iOS codebases still have Objective-C in production. Not legacy junk. Live, critical, mission path code. Interviewers use these questions to find out one thing. Do you understand the platform, or just the layer Apple built on top of it? Today, we are walking through the 7 most common questions with the answers that will actually land you the job. Before we continue, subscribe to support the channel and get more senior-level iOS content like this. Before the questions, let's set the context. The Objective-C runtime is a C library called lib-objc that runs on every Apple device. Swift itself interacts with this runtime. Method dispatch, class registration, it all sits on a foundation that Objective-C built. When they ask you about ObjectiveC, they are testing if you understand that the ground you stand on has a history with real consequences. Question 1. How does Objective-C method dispatch work, and how does it differ from a direct function call? In Objective-C, calling a method is not a function call. It is a message sent to an object using obc_msg send. The runtime looks up the implementation in the class's method list. If it fails, it walks the inheritance chain. This dynamic dispatch lets you do things impossible in a statically dispatched language, like method swizzling or runtime introspection. Swift uses static dispatch for value types, faster and safer, but it removes the runtime flexibility Objective-C provides. Question 2. Explain manual retain release, init, dealloc, and why any of it still matters with ARC. Before ARC, you were the memory manager. The rule was, every object has a retain count. When it hits 0, it's gone. When you write alloc-init, 2 things happen. Alloc gets the raw memory, init runs your setup code on that memory. These are separate for a reason. You can have multiple designated initializers all calling alloc once but running different setup. Retain is how you claim ownership. It tells the system, I need this object, do not free it. Release decrements the count. If you are the last owner and it hits 0, the runtime calls dealloc immediately. Forget a release, you leak. Release too many times, you corrupt. Pre-ARC debugging was largely the art of finding these bugs. Auto-release registers the object in a pool to be released later. It was essential for transferring ownership gracefully. In dealloc, you clean up resources. The call to super dealloc must be last, forget it, and you leak the object's shell. ARC didn't change the model, it automated it. It inserts those same calls at compile time. There is no garbage collector. This is why retain cycles still happen in Swift. ARC is testing if you understand what's happening where it can't help you. Question 3. What is the difference between strong, weak, and unsafe_unretained in Objective-C? Strong holds the object. Weak doesn't increment count and automatically sets to nil on deallocation to break cycles. Unsafe_unretained is weak without the nil out. You get a dangling pointer and likely a crash if you dereference it. Question 4. What is an Objective-C category? And when would you use one over a subclass? A category adds methods to an existing class without subclassing. You can even extend Apple's framework classes. Subclasses add state, categories add behavior. The Swift equivalent is an extension, but categories can't add stored properties. Question 5. What is method swizzling and what are the risks of using it? Method swizzling is swapping implementations at runtime. It's used in analytics SDKs to intercept behavior you don't own. The risks are massive. It's global, permanent, and hard to debug. In Swift, it only works on classes exposed to the runtime. Every abstraction has a cost. The best engineers are the ones who understand what happens below the layer they work in. Question 6. How does Swift and Objective-C interoperability work in a mixed codebase? Interop runs 2 ways. ObjectiveC uses Swift via generated headers. Swift uses ObjectiveC through a bridging header. The sharp edge is nullability. Without annotations, Swift imports ObjectiveC as dangerous implicitly unwrapped optionals. Question 7. How does key-value observing work under the hood, and what are its failure modes? KVO dynamically creates an ISA swizzled subclass at runtime, overrides the setter, and inserts notification calls. KVO is powerful but crash-prone. Modern Swift solutions like the observable macro are safer, but you must know what they replace. Understanding the runtime turns curveball questions into opportunities. It shows you know the foundation of the platform. Subscribe for more on architecture and system internals. Visit tony-trejo.com if you need senior-level guidance to scale your app. I'm Code Hero, and I'll see you in the next one.